And if you are in Windows, opening Anaconda prompt, like Anaconda, yeah, Anaconda prompt will give you at this location, like it will directly give you at base. Okay, so don't have to activate the base separately. Now I have my files, research, and then I just run Jupyter notebook on this on that location, right? It will fire up Jupyter notebook at that point. Okay, now for day 2. Let me, okay. Now I think, okay. Now we can start the second class. Okay, so today's agenda is basically to introduce the primitive data types, how variables are there in Python, or what is the main difference between variables in Python and C, right? And then okay, you have turned on the recording, right? Okay, cool. Okay, so and the input output, which I briefly touched on the first day. Then the operators and branching. Operators mean arithmetic, logical, and let's say comparison operators, right? And branching means the if else. That's it. So how we can do if else ladder and all these things in Python. And then the next, in the next section, which Gunjan will take, he will introduce these things broadly. Okay. Anyway, so primitive data types. So Python has like this basic basic two types of data types are there in Python. One is this primitive, that means all the, let's say, atomic data types like integer, float, boolean, strings. Like strings is not atomic anyway, so you can think of character is a atomic data type, right? Because you cannot break the thing into like similar small pieces, right? The integer, float, boolean, and let's say character. But there is no like specific character in Python. The string itself works as a character, so it can have one length or let's say n length. If it is one length, then we can treat it as a character. Okay, and if it has more than one length, then it will be acting as a string. And one new data type is there, which is kind of similar to void in C. Okay, so in C, when you, let's say, type data type as void, that means what? That you don't return anything, right? You return nothing. So similar concept you can have in Python with this non data type. Now, okay, so from today we will kind of focus on these primitive types. ADTs or abstract data types will be discussed in next upcoming classes. Okay, so primitive data types, I guess I have already touched upon this in the first class a bit. Like today we will go in deeper. Okay, so integer. So in C, integer is around what? Signed integer is around minus 36 some thousand something to plus 36,000 something, right? But in and the size is 4 bytes, right? But in like, is it 4 byte or 2 byte? Let me see. I guess 2 byte, right? Okay. Anyway, uh, so in Python, integer is like more than 2 bytes. Okay, more than 2 bytes, and it can have a larger value. And you see all the numbers, like all the natural numbers from minus infinity to minus infinity to plus infinity, all the natural numbers, like for example this minus 10, 1, 2, 3, let's say 50, all these things falls under integer set, right? So any value you assign to a variable which comes from this set, all the set of natural numbers will be treated as an integer. Okay, and the maximum value you see is like a lot bigger than what you are allowed in C, right? Now float. Okay, anyway, float is actually any value that comes from the set of real numbers. Let's say real numbers we thought it has fractional components, right? Minus 9.9 or minus even 1.0, which initially looks like an integer, right? Because it's a, but it doesn't have any fruitful decimal point, like dot zero is nothing, right? But even though it's because there is a like decimal flavor to it, right? 1.0, it will be treated as a float. Okay. Likewise, 1.3, 5.0, all these things will be treated as float. So whenever you have a point in the value, let's say 1.2, then it will be treated as a float. And the maximum value you can get with float is infinity. So infinity is a constant actually in Python. INF, INF, sorry. If you do float INF, right? So this value. This is the in say a equal to this, right? A is infinity. So this is, and type, if I check type of A, it will be float. Anyway, so all the will be treated as float, and the maximum value will be infinity. And then comes the boolean, right? Boolean takes only two values, true and false. Okay, we'll discuss it in the right side. We'll do code along with it. Anyway, and strings are actually like any set of ASCII or Unicode characters you can give, and any set of, or any combination of those characters will form a string. Even one character will also form a string, even though it should be treated, it should have a different data type, right? As C has its character. But in Python, characters and strings are treated like both treated as character. Okay, both treated as strings. And lastly, this non-data type. Non-data type is similar to what you have in C as void. So whichever is, let's say you don't want to return something from a function. What you do in the return type is void, let's say function name, and then list of parameters, right? And open and close the function, and at the end you return nothing, right? So exactly same thing. This void data type is kind of introduced as none type in Python, and the value is none. So what is none? See, nothing is printed, right? So if I just print none, see, none is printed. If I type none, it's none type, right? If I just do, let's see, if I just do one, it prints one, right? But if I just do none, see, it prints nothing. So that means none type represents the void in C. Okay. Anyway, okay. So in Python, variables are just like containers. Okay, you don't have to define its data type beforehand. In C, what you usually do, you define the data type at the beginning or at the top of the code, right? You define the data type that okay, A is a integer type variable. So you cannot assign a float to A. If you assign it, what would happen? It will the floating point values will be truncated, right? And the only the integer part will be stored in A. Right, the variables will remain as int in C, right? But in case of Python, variables act just like containers, and they can change their data types as you keep assigning or binding new values to it, right? So let's say I have a equal to 100, right? If I check type of a, see, it's int. Now same thing, a equal to, I'm reassigning the value of a, right? I'm a equal to 1.23 and check the type of a. It will be float. See, the data type itself changed for a, right? And I have never defined the data type for a. You see, I have not defined a is a int or a is a float. A is just a variable which I am assigning the value a, and before using the variable I don't have to declare it as well. So In Python, you don't have to declare the variables. You just have to initialize or assign them before using them in any computation. So if I just do this, like let's say a times b, a is there, I have initialized a as 1.23, but because b is not there, b is never initialized, it will say name error, b is not defined. Now if I just do b equal to, let's say, 2, okay, now a is also there, I have initialized it to 1.23, b is also there. Now it should not throw any error, it should print what, 1.23 times 2, right? 1.23 times is 2.46, yeah. So in Python, you don't have to declare any variable beforehand, but before using it for any computation, you have to initialize it, okay, with some value, let's say. Okay. Anyway, so if I just let's say coming back to this container type thing, right? So if I just assign a is hello, now if I check type as a, it's a string, right? So a changes its data type as I'm kind of reassigning different like values to a, right? Based on the values, it will change its data type. Good. Similarly as none. If I do a equal to none, right, and check if it type of a, then it will be a none type. Cool. Okay. Now you can cast these primitive data types to all other primitive data types, right? So just like C, in C what you do, if I want to cast a floating point variable to an integer, right? So what I do, int a is equal to this notation, right? Int and then float, let's say 1.234. In C, this line would cast this value to a int, and a would and kind of what I expect as a is equal to 1, right? In this case, this all decimal points will be truncated because I am casting a floating point variable to an integer. Now in Python, same thing happens. So it's like whichever data type has larger, like is allocating larger space is memory, right? So that means it has more granularity or more resolution in representing some value. Integer and floats are different at that, like at that scale, right? So integer can only represent whole numbers, right? Whereas floating point values can represent it's a fraction of values also, right? Like 2.34 or something like that. So the main difference is the degree of granularity it can represent, right? So if I, and let's say whichever has higher degree of granularity, we kind of tell them as higher data types, right? So if I cast a higher data type to a lower data type, there is a chance of data loss, right? So let's say 1.23, if I cast it to integer, the whole decimal part will be truncated, right? So data will be lost. But if I cast one, let's say 1 to float, what it will be represented like 1.0, right? So no data is lost at least, right? So if I cast higher data types to lower data types, that means there is a possibility that data can get lost. Whereas if I cast lower data types to higher data types, then there is no no point of losing any data, right? Because it's a high fidelity, like high resolution, high okay, you can represent the same data in higher resolution, right? Anyway, now we'll see how, like, what are the how to convert these like integer to float and integer to boolean, all these things, right? So let's say I have a variable a which is integer, let's say 11. So if I want to cast it to a float, what I will do is float a. See, 111.0. So it's casted as a float. Okay. Now, if I want to cast the same integer to a boolean, oh sorry, not float. See, it's true, right? So in case of boolean, there is one catch. So how it's converting the integer value to a true or false value? It's like if value is not 0, then true. This is the logic for converting any integer or any floating value or any string to a boolean. So if the value is not 0, for let's say string, if the length is not 0, float is same. Like if the value is not 0, then it will create a true variable, right? And if the value is 0, let's say boolean 0. See, if it is even if it is negative, right? 11 1 to minus 1 on 2, then also it will give true because the value is not 0, right? But if I just give 0, it will give false. So the conversion logic is this. So if the value is 0, then not 0, then it's true. Okay. Now string. So if I cast an integer value a to a string, it will look something like this: quotation and then 11. So no logic, something nothing mysterious like boolean, right? So it's just the character by character conversion, right? Okay. Similarly, float you can convert to int. The value will be truncated. So let's say let's say 11.23, right? And then if I cast it to int, see the decimal place is truncated. Only 11 is there. Now, if I cast it to boolean, see it's true because if the value is not 0, right? But if I pass 0.0, see it's false. So in float, 0 means 0.0, right? Anyway, okay, it's true, fine. And if I cast the same value to string, see 11.2. So the string conversion is just like character by characters conversion, right? So each digit will be converted to a equivalent character, and this quotation marks denotes a string. Now let's say boolean you already know. So let's say b equal to 2, right? Yeah. Now if I want to cast it to int b, see it's casting it as a 1. Now if I do it as a false, it will be casted at 0, right? Okay, anyway, and float is similar. Float b 0.0. If it is true, then it will be 1.0. Let's see, 1.0, right? And then string is similar. It will cast the b true, right? Character by character conversion of the true, this value. Okay. And string is string s is equal to say hello, right? We cannot cast s to int because it doesn't have any like literal base 10 value, right? So hello cannot be casted as a string. So this age is invalid, right? But what you can do, you can cast a character actually. So if I have h, oh sorry, so you have to do it anyway. Okay, we will touch upon this later. So at this point, we cannot cast a string to any integer or any float. You see, if I cast it as float also, right, it cannot be converted. But we can convert it to a bool actually. So bool of s. You see, it returns true. How it is returning true? The logic is if length of string is greater than 0, then return true. Then return true. Okay. So if the length of the string is like 0, right? Let's say s is equal to only this. Nothing in like no character in between, right? So the length of the string will be 0. Now it will return false. Okay. Cool. Now the typecasting is similar, like something like this. You can convert, like string cannot be converted to equivalent integer or float, but you can have their ASCII value. So if you have a character, you can convert the character to its equivalent ASCII value. Okay, we'll touch upon it on, like, later. We'll touch upon this. But directly you cannot convert a character to a integer or a float. Okay, or equivalent string to integer or a float. Okay. Anyway. Now arithmetic operators. So what are the operations you can do with all these data types, right? So operation. Now let's say arithmetic. Anyway, so addition. So let's say we will first go over all these things with integer, so that exactly similar to as float, right? So integer and float have similar operations, but string has some different, like string behaves differently with these operations. So and some of the operations are not also applicable to string, like to the power is not applicable. Okay, so okay, anyway, we'll see for integer and float what are the operations you can do. Let's say a equal to 5 and b is equal to 10. Okay, so I can add them, their value would be added, right? I can subtract them by like this, minus b. I can multiply them, a times b. I can divide. So it's the single slash operator is actually float division. So the value returned will be float. Okay. So a divided by b, you see 0.5, right? But if I also do b divided by a, that would be also 2.0. So this slash division will be float division. Okay. So even the division returns a whole number, it will be represented as a float. But there is this slash slash division as well, that actually gives you floor division, or whatever the decimal point there will be, that will be truncated. Okay, so it's something like integer division. Okay, so a divide by b, so double slash, that is a 0, right? Previously it was 0.5, but because it's a integer division, it will result 0. So the 0.5 part is truncated. Similarly, a divided by b, oh sorry, b divided by a, it return gives you 2, right? Okay, modulus operator is also there. That is the remainder operator, similar to C, right? So if I do, let's say 16 divided by 3, so it should return 1, right? Because 1 will be remainder. Yeah. And this will be always a integer value, because remainder cannot be fraction, right? Remainder is always integer. So whatever the let's say the remainder of a division operation, that would be represented by this, say 100 divided by 3, 1. 99 you can reach, 1 you cannot reach, right? So there is one, if I do 4, or 4, you can 25 times 4 equal to 0, equal to 100, right? 5 is also the 6, 4. So 6 times 4 means you can reach up to 96, but 4 you cannot cover, right? So remainder is 4. Okay, the power operation. So in C there is no direct power operation, right? So you have to use the mat.h library, the power function, to compute a power. But for Python you can do it like this: 2 star star star, only single star means it's a multiplication operator, and then if you have a double star, that's something you're powering the right term with the left one. Okay, so 2 times 2 to the power 3 is represented something like this: 2 to the power 3 star star 8. Okay, so you don't have to use any external library to like have this power computed. Okay, so and the power can be computed on floating point values too. So 12.9, you see, Okay. So all these operations are actually valid for float too, but in the the integer division part, let's see, to say 5.9 divided by 2.3, 2.4. Yeah. So the integer division part, like it also returns a floats for floating point value. Okay. So and the difference you can see if I just do this, right? You see it returns a float because the two operands are float, but it truncates the decimal places. Okay. But in case of integer, it will return integer. And the funny thing is, if I let's say if one of the operand is integer and other one is float, then also it returns a float. So what it actually means, it uh, among the two data types which are operating with each other, whichever has the higher data type, the result will be returned on that data type. So you see, so because these two data types, one has int and one has float. Float is obviously higher data type, right? Because it can represent some value with more fidelity. So the resultant value would be in float. Okay. Anyway, now strings. So strings, make most of these operators are like, I guess 2-3 operators are not possible to execute on a string, but like strings behave differently for each operator. See, you can add to numbers, right? But how it will happen if you add to strings? So it's not like all the characters will add up with each other, right? So it would be something like this. So let's say you have two strings A, B, C and D, E, F. If you add them, they will be concatenated actually. Okay, so it's something like this. Let's say A, B, A, B, C, B is D, E, F. If I do A plus B, they'll be concatenated. So addition logic is clear. I can concatenate strings that would represent addition operation, right? But how would you represent subtraction operation? You cannot subtract strings, right? Or you cannot, let's say, you cannot delete a set of characters from a, it's a set of characters, right? You cannot do that. So so A minus B is not valid. You see, unsupported operand type for string. So you cannot subtract two strings, whereas you can add two strings because addition logic would be represented as concatenation. Now multiplication. So you cannot directly multiplicate two strings A times B, right? A is C, A is ABC, B is D, F. A times D. You cannot do it, but you can multiply a string with a, let's say A, B, C, and multiply a string with a character with an integer actually, not a float. You see, float integer is not possible. Float and string multiplication is not possible. But for integer, if you multiply integer with a string, it will represent the repeat operation. So the string, the substring will be repeated, let's say n times. Let's say n equal to 3 for this case, n times in the resultant string. So if I just change it to 10, right? So the resultant string will be ABC 10 times. Okay. Similarly, you cannot divide two strings. Okay. So if I just do even this operation doesn't happen. So if I just copy this string and divide by 10. See, the reverse operation doesn't happen, right? So even if you can multiply string with 10 and it will result 10 times concatenation of the same string or repetition of the same string, but you cannot divide the resultant string with the, let's say, the same value, and you would not get the ABC value. Okay, and one thing, like strings are represented both with this double quote and single quote. Okay, so these are interchangeable. So you can also use double quote for representing any string, or you can use single quote to represent any string. Okay, so which is different in C, because in C, I guess double quotes means a string and single quote means a character, right? But for Python, both are same, so you can use them interchangeably. Now same thing, division operator is not valid. Same thing, integer division is also not valid. Modulus is also not valid, right? Modulus, you cannot do modulus on string, right? And then power is also not valid. ABC times 60. You see, power operation is not valid for string. But because you cannot power strings, right? Logically it cannot happen. But you see, what are the operations that are valid on string? This is multiplication operator, because you can kind of think that multiplying one string is kind of repeat operation, right? And addition, because we can think addition is just like concatenation for string. Okay. So only multiply and add operations are valid for string. All those other operations are valid for integer and float. Okay. See, these are arithmetic operators, right? So you can only apply those things on numbers. You cannot apply numbers, or let's say for some cases for strings. But for the Boolean data type, you have these logical operators. Later on, we'll discuss logical operators. How you can, like, Boolean operators Boolean values can be also operated with each other with logical operators. Okay, so we'll see it later. Anyway, comparison operators. So you can compare two values with all these operators. Same as C. See, greater than, less than, equal to, not equal to, greater than, equal to, less than. These are exactly same as C. So I guess you can check whether the left side variable is, let's say, is in some relation with the right side variable. All these relations are represented as greater than, less than, equal to, not equal to, greater than, equal to, less than, equal to. So let's check one thing. 100 is greater than 99.9. Okay, it will be true. Okay, see, if I just do, let's say, 999999, it will be true, because true. Now see, if I increase the 999 to a significant point, right, it will return false, because now they are equal. So it's just like how Python is up to which precision float is storing floating point. Python is storing floating point value. So 99.9999, this Python treats close to like this 100. Okay, so it's kind of approximated as 100. These are like round, like these are floating point issues. Okay, so floating point values can approximate an integer value. So up to which decimal point it will be significantly less than this integer value. This like entirely dependent on Python. So I guess up to which point it will be okay. See, now okay, up to, now false. Now if I add another 9, it will be false. Another 9, it will be true. So up to 1, 2, 3, 4, 5. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So up to 15 decimal place, it will treat like up to 14 decimal place, but let's say 8. Okay, 8 is also there. So if I do 1, okay, 1, 2, 5, it's true, right? So up to this value, okay, up to this value, 100 and this 99.9999 value are different. They are false. If I just increase one decimal point, it will be true. So Python cannot represent this whole value like correctly, right? It returns 100. Okay. So these are like floating point issues. Okay, you have to be cautious how system is kind of approximating your computations. Okay. Anyway. Okay, these operations are clear, right? So you can, let's say, if I want to check, these are not equal to this. Also, okay, these are equal actually. So Python represents both these values equally in system, right? So not equal to returns false. Okay. Cool. Now comparison operators are done. Now if I these are logical operators. So logical operators can only work on Boolean data type. So let's say I have a value a equal to true and b equal to false. So notice this T and F are capital. Okay. Now if I want to AND them, AND is logical AND, right? So what is the truth table for AND? AND truth table. AND hash is like one line comment, similar to // in C. So AND has if I have both the variables 0 0, it will be 0, 0 1, it will be 0, 1 0, it will be 0, and 1 1, it will be 0, right? So for this case, one is for 1 1, it will be 1. For this case, one is true, one is false. So we should see after ANDing them, it will return false, right? A and B, false. So if I have both these variables as true, then I should get true and true, right? Similarly, OR operation. OR. OR is 0, this is 1, this is 1. So OR is something like this, right? So I have both of them as true, so I should get A or B, A or B. See, for C, these operations can be represented like this: A and B, right? And this operation is represented A 5 5 B, right? So in Python, these are similar like A and B. You can, instead of writing these two AND symbols, you just write A and D in English. Okay. So you see, if both of them are true, I have A or B equal to true. So now if I have any one of them as false, the value would be still true. If I have both of them as false, then only OR operation will give you false. Right? Not is a unary operator. It's like only change the logic, right? So you can, okay, not true means false, not false means true. Okay, fine. So logical operators are like this. So for Boolean variables, you can do AND, OR, and NOT. Okay. Now IO. So I guess I already touched upon this briefly on the first class, but here we'll just revise that thing once again, because later you have also code along task. So I just remind you how to write print statements, and then you can use it in your task. Okay. It's a print. I want to print hello world. Okay. Say you see, by default it prints a /n, or it prints a new line after in between two consecutive print statements, right? So there is actually these two variables, these two values, this separator and end is default /n, right? And the and where it outputs, actually it outputs in the system.stdout. So your screen, right? It outputs on the screen. So actually this end equal to /n, this is responsible for this new line. So if I just change end to be a comma, space, comma, let's say just comma, then you see these two print statement result in only separated by the comma. So by default it's actually /n. Okay. So that's why you have new line character in like both consecutive print statements. However, there is another variable, this separator, right? What it does, you can print actually multiple statements in the same, let's say hi, one string, comma, my name is, all these are different strings, right? You can separate it with comma. Let's say neo. Okay. So if I just print this, you see all this, even though I have not specified that, okay, separate them in spaces, right? I just provide them as raw, right? Like, hi, my name is Neo, and then I just print them, I just put them in the print statement. You see the print by default separate them in spaces. So that is defined with this shape parameter. If I just put shape equal to separator is equal to dash, right? You see all the strings are now separated with dash. Okay, so by default it's actually space. By default it's like this. Okay, and one important thing is you can see the documentation from notebook with shift tab. If you just click in between some call and do shift tab, you can see the docked string of the, you see separated is by default space and end is by default slash n, right? And you can just read what are, like, let's say in this doc string nothing exciting is written, right? But for, let's say, advanced libraries or something like that, the entire working procedure of the function as well as the description of all the parameters and how it let's say expects and how it returns, all these are written in the doc string itself. So if you want to read any documentation of a function, you can just give the name, call it, and do shift tab. Okay, together. Then it will pop up the dot string. And you can scroll and read through the documentation, what it expects and how it is returning the value. Okay, cool. Now these two parameters are actually really important. How you format output. Okay, so if you want to print multiple, let's say if I have a loop and then I want to print all the outputs in one line, so I will change this end character, right? Now if I have multiple things printed on the same print statement, I would change the separator if I want to separate it with any other character than space. Okay, and the return value of print is none. Let's see if it is written on its doc. No. Okay, anyway, if I just catch the return value, right, a equal to print. Now if I check a is none. If I check just type of a, it's a none type, right? But for C it's different. Printf returns the length of the string that is printed, right? So yeah, returns the length of the string in C. But for Python it returns none. It doesn't return anything. Okay. Okay. Now for input, how it should take input. So input is in case of C it's scanf. For Python it's like just this input function, input, and then it's optional actually. You can give or not give the prompt. So uh, input one is equal to input. So there is a prompt you can give, but it's optional. You can give or not give, right? So let's say I give 1 2 3. Now if I check input one, it's actually a string. So what it takes a optional prompt for the user, so that user know what value he is supposed to give, and it returns a string. It's like just the keyboard buffer. It returns as a string. So if you want to let's say if you want to have a float or integer, you have to cast it. Okay, before after taking the input, you want to also cast it to have an integer or a float. Okay. So let's say I want to have a prompt, enter a number colon space. Now if I run this, you see enter a number, it shows up as a prompt, right? Enter a number. So if I just enter a number 1 2 3, enter. So now input 1 is 1 2 3. Now it's not in integer, right? I want to have a number because it's a string. So I can cast it to a integer. Now it's a integer. So input 1 equal to this. So executing both these statements together, right, in the same cell, would have the effect of scanning an integer. 1, say integer. If I check type of integer, say integer, because I have casted it. Right? So now I can, instead of having this in 2 lines, I can also have it in 1 line.
Hi everyone. Can anyone else hear Prasenjit? You can unmute and say.
Yes, sir, we can hear you.
Okay.
Okay, actually, the current is gone off actually, so the campus Wi-Fi is off. I will try to share it with my mobile data. Let's see if it is visible. Okay, you can see my screen, right?
Yes. Screen is.
Cool.
Maybe
Then
you can shut down your turn off
until
your video. Like, that will save some
okay.
time.
Okay. Now you see here, I can take input as integer, cool, and then I can also take float, integer float, right? Integer float. 1, 2, 3, 1, 4, 4. Yeah, type of
Your
this is
notebook
float,
is
and
not
if I
visible.
check
Yeah.
notebooking,
Now it's visible. That's fine.
actually, I think this will be some lag, right? Because on mobile,
Yeah. That's fine.
yeah. So, okay, input output is something like this. So you can take input as like the input will be always taken as a string, and then you have to cast it to a proper value, like whatever you want to scan. Let's say float, integer. And if you only want to scan a string, then you don't have to do anything because it's already written you as a string, right? Cool. And okay, input returns the keyboard buffer as string. Cool. Uh, Now, branching. I guess Gunjan, you can take off, right? Because here the network is slow. So if I just if it is laggy, then it will be hard to understand, right? So I guess you can share your screen and go along with it, right? Okay, so I'm stop sharing. Wait, stop sharing. Yeah.
So let's see. Is my screen visible?
Yeah, you can see it.
So it is still recording and not because. Okay, it is still recording. Yeah. So as you might be aware with the branching constructs that are there in C, so here we show a basic example using an if-else statement. So we have a number which is equal to 10 and we want to check whether it is positive or not. So we put a condition to see that if number is greater than 0, then it will print positive number, else it will print negative number. So we can just see how it works. So number equals to 10 if number greater than 0, we print positive, else we print negative. As expected, when I run it, it will print a positive number because 10 is greater than 0 will return true, and we will see that this the flow under this statement, this if statement will execute and will print that it is a positive number. And whatever else is outside this if else statement will always be printed. So for example, if I just add a statement like print uh, this block, this statement will be printed, then that statement will be printed irrespective of whether the number is positive or negative. So this is what a block looks like. So number equals to 10, we did the initialization. Then there is this condition that if number is greater than 0, so this will correspond to the yes block, that yes, it is actually a positive number and it will print it as a positive number. Else it will print a negative number, which is the block for no block, that it is not a negative number, and finally the end of the program. So this is how a flowchart will look like. Then, so in case of C, if you have to write a if-else statement, you have to make sure that they are within the within close within these parentheses, right? Within these curly brackets. Whereas in Python, to make the flow of if and else, you have to make sure that it is properly indented. So, like here, if you can see on the right, in my notebook, I've given a tab which is a 4 space which is equivalent to 4 white spaces, and after writing the if statement I have given this print statement after 4 spaces which corresponds to the block of if. So if I want to keep printing statements inside this if or execute some logic inside this if, I have to make sure that every statement that follows after this statement will have a 4 space gap in the beginning. So let's say if I want to print that this is inside the if block, then I have to make sure that the start of the statement is 4 blocks is 4 space from the beginning. So if I execute this now, this statement is inside the if block. This part is also printed. Similarly, if I want to do some arithmetics, like let's say I initialize a number a equals to 5, and if I say that okay, I want to increment 5 if the number is positive, and I do a equals to a plus 1, and I print a, and you will see that a is now 6, whereas when it was initialized before it was 5. So you have to make sure that when you are writing a code in Python, indentation is the key. So just in C, we have to make sure that everything is enclosed in brackets. For Python, we have to make sure that everything falls under the same indentation level. And if there is an issue in indentation, Python will throw an error that unindented does not match any outer indentation level. As you can see, this statement on which my cursor is on and the print is highlighted in red, it is not correctly indented with either of the previous statements, and it will be correctly indented only when it has 4 tab spaces. So 1, 2, 3, 4. When it has four spaces, it correctly indents with the line above it and falls under the statement of if loop of if part, and now it will not throw any error. Okay. So moving on, as I was saying, that indentation are necessary for a proper definition of Python blocks. It is usually 4 spaces, or you can also like usually 4 spaces, which corresponds to 1 tab press, or you can also have like varying level of spaces. Like in if you can have just 2 spaces. Even when I have this kept as 2 space indentation, still it is working. It is not showing any error. And similarly, in else statement, I can keep like maybe 5 spaces, still it will not throw any error because the indentation is local to a block. It does not go across blocks. So here I am showing an example where for if statements there is two space indentation, whereas for else statement there is a 5 space indentation, and still nothing is wrong. So even if I change, like if you want to see whether the number, so if I keep it like -3, this time it will just print negative number, and this statement is anyways printed. Now just like there is concept of nested if else in C, there is also this condition of nested if else in Python, and it looks like this. So if first condition, then we go into inside that block, and there is another condition of if, and when condition 1 is true, which is here, it will execute the block between these two things, and if condition 2 is true, then it will do whatever is present inside this condition 2 block, and the first if blocks ends here and the second if blocks ends here. And this is what the control flow would look like. Our test expression, if it is, if the first expression is false, then you then you check whether the nested test expression. So if that is false, then you move outside the body of, then you go to the body of the nested else, and then you just execute the statement below it. But if the test expression is true, you execute the body of if, then you go the statement below it. So for example, in this case, if condition 1 is true, we will execute the statement when the condition 1 is true, and then we will see that if second condition is also true, then we will execute the condition whether we will execute the condition that is present in the if block of the condition 2. So for example, let's say we have two numbers, t equals to 5, like n equals to 5 and m equals to 10, and I want to check that if I equals 5, then I have to do something. So let's say I'll just print I equals to 5, print I is 5, and then inside this I will have another if, so it will just print if m equals to 10, then I'll just print uh, I is 5 and m is 10, else I will print I is 5 and m is not 10, and the outermost else, which is for this if I equals to 5, so it will look like else I is not 5. So we will have something. I is not defined. Sorry. M is 5 and it is just printing that n is 5 and m is 10, so both of these statements are printed. Now if I change m, so it will, like if I put it 15, then it will check I is 5, but inside this if, since m is not 10, this statement will not be executed, the else part of this will be executed, and it will say it will print I is 5 and m is not 10, right? And when I change n itself, it will just say that n is not 5 because it will not go inside this nested if condition. Okay, now moving on to the next thing. So there is this if else ladder, so we can keep on checking conditions, like first test condition, if that is true, else else if, that means if the first condition is not true, then check for the second condition, then check for the third condition, and so on till you reach the body of else, and then you keep the execution flow. So let's say I have a number m is 15, and I want to check whether it is between 0 to 5, 5 to 10, or 10 to 20. So I can just write like if m is less than 5, is if m is greater than 0 and m is less than 5, then I will print in 0 and 5. If, and in this condition I will put m is greater than equal to 5 and m is less than 10, and I will say print in 5 and 10, and else I'll just say that m is greater than 10. So if I execute this, what do you think will be the output of the what would be the output of this if else ladder? So first it will check whether m is between 0 and 5. Since it is not, it will go for the next statement, and next comparison is between 5 and 10. Since that is also not true, it will go to the next part, which is the else statement, and there it will say that since neither of this is true and this is the default statement that we kind of have, so just print m is greater than 10. And if I put it something like and if I put something like negative, then also it will say that m is greater than 10, because we have only checked whether m is greater than 0 and m is less than 5, but uh, we have not put a separate condition whether we say that if m is less than 0, then print that. So if neither of the above conditions holds true, then the default part, that is the else block under the else logic, will be executed. So here it just printed m is greater than 10, right? And if I put something like 4, then it will say it is between 0 and 5. And if I put something like 7, then it will say in 5 and 10, because this part got executed. And as usual, if we have a statement in the end, so for example, print value of n is, and I just print m, then it will execute this part without without even bothering about what is inside the if else logic. Okay. So moving on, the next part that we have is for today's task. Okay. So your first question that you can try on your own, and I will be also solving it shortly, is take three integers as input and find the maximum and minimum out of them and print. Okay. So for those present in this room, if any one of you has set up the set up the coding environment and would like to give it a try, you can try this for the next 5-10 minutes, and let both of us know. We can give a 5 minutes break so that you can try this question, or if you have any doubts, you can ask me.
Yeah, anyway, we'll after these 5 minutes, we will just
Yeah,
show you
solve the problem for you.
Okay, and if you have any doubts while coding this, you can also like unmute yourself and speak. That, okay, this is the part which I am not understanding.
By the way, you can also comment on the pace of this course, like if you want us to slow things down, or if you want to teach things slowly, or anything. If you're facing issues at that level, you can also share your feedback with us in the meantime. Okay, so we can also give, like, just to help you to solve this problem, we can kind of discuss a pseudo code. So think of this if else ladder that we were discussing. So there is since there are three numbers, basically you need to compare at every step that a number under consideration is greater than all the other two. So here, since there are three numbers, you have to write one if, one elif, and final else condition, which will be the default one in case the above two is not satisfied. And in each of these if and elif, you have to check that a number is greater than the other two. So if you are doing it for the first number, then you have to check that first is greater than second, and first is greater than third. Similarly, in elif, you will check whether second is greater than first and second is greater than third. And if both of these are not true, that means third is the biggest number, and you will print that number as the maximum. And similarly, in the for the minimum case, you will reverse the conditions. So if like a is smaller than if num1 is smaller than num2 and num1 is smaller than num3, then that is your smallest number. And if num2 is less than num1 and num2 is less than num3, then that is your smallest number. Else num3 is the smallest by default, because both of these numbers were not the smallest among all. Maybe you can raise your hands if you are done with the coding. If you're done with this code. It's relatively easy code if you are familiar with basic coding syntaxes in C and Python. So
So guys, if you have any doubts in the syntax, you can just let us know, and otherwise we'll just show you.
yeah, I think we can just share the solution. So yeah, this is what it would look like. So, let me just- yeah. So Python code for finding. here is what I was discussing earlier. So we have three numbers, 1, 2, and -3. So first we will check that 1 is greater than 2 and 1 is greater than -3. So 1 is greater than 2 was false, so this part will not be accepted. Now y is greater than x, which, and it will go into this elif part, right? Because this statement was not true. Now in elif, it first checks whether y is greater than x or not, and 2 is greater than 1 is true. So that is true. Then it will go to the second part of the end condition, which is y is greater than z, and y is 2, z is -3. So y is greater than z is true. Hence it printed y is largest, and the value of y was 2, so it printed 2 is largest. Similarly, if you change values like maybe 10, 5, so in that case, it will print 100 is largest. So first it will check x greater than y. So 10 greater than 5, true. Then it will check x greater than z, 10 greater than 100, false. So not this one. Then it will go y greater than x. So 5 greater than 10, false. So not this one. Hence it will go to the default, which is under the else block, and this it will look like it will print z is largest and the value of z is 100, so it will print 100 is largest. Now, if you are just having one line expression inside if else, you can also keep it next to the condition. You don't need to put spaces and indentations. You can just write next to that and it will also execute without any problem. This is valid only when you have like one statement inside that if logic that you want to execute. If there are multiple, then you are bound to indent the code in a similar fashion. Otherwise, it will throw an indentation error. Okay. Now, this was for finding the maximum, and if you want to find the minimum, then you need to just reverse the sign that x is less than y and x is less than z, y is less than x and y is less than z, and then here it will print the small x. Here, like it checked x is less than y, so 10 is less than 5. That condition became false. So then it went to the second if else, if second elif statement. So it found y is less than x, so 5 is less than 10, which was true. Then it checked the second part. So 5 is less than 100, that is also true. And since both of these statements were true, it printed that 5 is false. And like this, you can check whether you can find out the maximum or minimum of the integer using this simple if else comparison.
Like we might want to discuss this format of operator in here because we have not discussed it earlier. Yeah.
Yeah. So like yeah. We can also discuss in the next class, but yeah, I think it's fine.
Yeah.
So if you want to like this is a formatted string, right? If I hope you can see the difference. So earlier what Prasenjit was doing is he was writing like this, z comma is smallest, right? But sometimes you might find it tedious to break statements in between. So what you can do is you can just put an f in front of the string, and whenever you have to put a variable, you use these curly brackets and put the variable name inside that. And when it will be printing, it will use this formatted string and it will print the value of the variable wherever the variable was mentioned inside the parentheses. So just to show you the difference, if I write z simply versus when I write the z as in the variable format, it will print like this. So z was plus. So you can see, right, z. The first z was just printed as z, whereas the second z, which was inside the curly braces, it was printed. Its value was essentially printed. So yeah. Another way you can do print is like you can do the standard way we used to do in C. So you can do like print percent %d is my number, and see you follow the percentage arguments with comma, but here you need to put the percent. And if there are, since here there is just 1% d, I don't need to put any braces or anything. I can just write percent x and it will just print n is one number. And when there are multiple like percent d, I need to put this inside braces. So x comma y, and it will print 10 comma 5 is my number. And if you want to set like if you want to set like if you want to set the uh, number of floating points. So if it is a floating point integer, and if you want to say that okay, I just want to print up to second decimal place, so I can also do that 10.325, and the syntax will just print to the second floating point because of this 0.2 f statement. So these syntaxes are similar to what you use in C. It is just how the arguments follow. So in C, what you will do, you just put comma and do it and uh, write the variables that needs to be filled. Whereas in Python, you put a percent sign, which is for formatting, and then you put the variables in the order it should appear in the string. So here, like percent %d, so this percent %d will be replaced by x, and this 0.2f will be replaced by the second argument, which is 10.0. I find this method to be the most comfortable, the string formatting inline, whereas you can also use this kind of formatting if you want. There is no such I would say there is no hard and fast rule that you should follow. It's just what you like.
Yeah, so you have to write less number of characters, right, for the string formatting.
You have to write less number of characters, exactly.
Yeah, that's why we are comfortable with that.
Yeah.
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 So moving to the second task for today, and this one is on printing if an integer is odd or even. Okay. So you are given an input integer, and your job is to just check whether the given number is even or odd. So maybe you can give this one a shot and let us know. Also, let us know if you have any doubts in the earlier problem. Like maybe one of you can unmute yourself and speak. That were you able to solve this, or were you not able to solve this on your own? Okay, so in case no one is replying, I'm assuming that everyone is able to understand because I'm an optimistic guy, but I think percentage will be the other one which says that no one is understanding anything. So okay.
Yeah, I guess they are understanding that. Yeah. No.
Okay. So the second question is that given an integer, you have to check whether the integer is even or odd. So as you might have done this in your basic programming 101 classes in first year, so this is a very simple thing. You take the and here we can also do one more thing. Instead of hard coding, we can try input statements. So input give an integer and we take n. So if and then we also typecast n to n, so it will be n is int n, and then we check if n mod 2 is equal 0. So if n mod 2, and this will return 0 if given, else it will return 1 if odd, right? So if n mod 2 is equal to 0, we will print if n is n, and we can also print the value of n. So n is given, and else we will print n is odd. Okay. So if I give an integer like maybe 157, you will get 157 is all. And if I just do this, if I don't compare, right, then it will say, then let's see what happens, right? It will say 157 is even. Now, why that is happening is because, as Prasenjit discussed this earlier, that 0 represents false, right? And you are checking whether n mod 2 is 0 or not. So, since it is 0, that means it should be true, but this if statement is making it as false, and we will flip our choices. So, if you are not directly comparing, and we are just stating that if n mod 2, when it is even, it will be 0. So, and when it is 0, it is even. So, instead of triggering this if, it will trigger the else part, and you will get n is even. So, just for taking it, now it is printing n is even, right? Okay. So, yeah, I think we can call it a day today. It has been almost 1.5 hours now. So,
Yeah, I can close up, right? So it's already covered up till the branching part. So I guess next
and
day we'll cover the string operations.
yeah, string operations and control flow logic.
Yeah, and looping, right? How
Yeah,
you
string.
okay.
Okay.
Uh,
So, yeah, thank you everyone for joining, and we hope to see you again in the next class.
and we'll share the video link and the this presentation with in the Piazza. Right?
Yeah. Yeah.
Okay.
Okay.
You can close up by.